Can James Webb see Pluto? Hi guys, welcome to Tech Future. I know many of you guys including me have wondered about that at least once. So today we'll be finding out exactly all the answers to this question. Without further ado, let's begin. Before that, make sure to subscribe and like. Thanks. The first solar system discovered outside our own was a pulsar, not a main sequence star like our own. To say the least, it was unexpected. Since then, we've discovered thousands of exoplanets, in every type of star system imaginable, and we're still looking for smaller, more Earth-like planets. In order to look for the elements of life elsewhere in the universe, the Space Telescope will study the atmospheres of exoplanets. However, Webb is an infrared telescope. What benefit does this have for exoplanet research? The transit method, in which Webb will look for a star's light to dim as its planet passes in front of us to observe it, is one technique it will use to study exoplanets. Astronomers refer to this as a transit. We can measure the mass of the planets through ground-based telescope collaboration using the radial velocity technique, that is measuring the stellar wobble caused by a planet's gravitational pull, and Webb will then perform spectroscopy of the planet's atmosphere. Webb will also be equipped with coronagraphs, which will allow direct imaging of exoplanets near bright stars. An exoplanet image would be just a spot, not a grand panorama, but by studying that spot, we can learn a lot about it. This includes its color, seasonal differences, vegetation, rotation, weather, and so on. How is this accomplished? Again, spectroscopy is the answer. The science of measuring the intensity of light at different wavelengths is known as spectroscopy. Spectra are graphical representations of these measurements that hold the key to understanding the composition of exoplanet atmospheres. The starlight passes through the atmosphere of a planet when it passes in front of it. If the planet, for example, has sodium in its atmosphere, the star's spectrum, when combined with the planet's, will have what we call an absorption line in the place in the spectra where we would expect to see sodium. This is due to the fact that different elements and molecules absorb light at different energies, which is how we know where in a spectrum we might expect to see the signature of an element. Scientists want to learn more about our own planet as well as planets outside our solar system. Webb actually complements NASA's other solar system missions, such as those on the ground, in orbit around Earth, and in deep space. Data from various wavelengths and sources can help us build a more complete picture of the objects in our solar system, especially with Webb's unprecedented improvements in sensitivity and resolution. Webb will study Mars and the giant planets, as well as minor planets such as Pluto and Eris, as well as small bodies in our solar system such as asteroids, comets, and Kuiper belt objects. Webb will help in our understanding of the trace organics in Mars' atmosphere and will be used to conduct research that will validate the findings of the Mars rovers and landers. Webb's observations of the outer solar system will be combined with Cassini's Saturn observations to provide a more complete picture of the seasonal weather on our giant gas planets. As for asteroids and other small bodies in our solar system, there are some features in their spectra that Earth-based observatories cannot see, but Webb will. Webb will contribute to our understanding of the mineralogy of these rocky objects. That's it for today, guys. Hope that answered your